So in this video, we're going to take a look at what are called voltaic, aka galvanic cells. One application of this is something called a battery, and we've actually created a battery right here with our lemon, and the lemon battery has electrodes that are called zinc and copper, and you can see we've got a little bit of voltage right here, or a little bit of electrons flowing from one to the other, and if I disconnect the wire, then the electrons won't flow anymore. And when I connect it back up, you can see that we've got about 1.2 volts on my voltmeter or my little multimeter. If I replace one of these pieces of metal, like for instance I put a piece of iron in here instead of zinc, you'll notice that my voltage or my multimeter reads a lot less. That's because metals, or all substances actually, all have a different want or desire for electrons. And how much they want or desire electrons we'll actually put a numerical value to in number 4. But before we do that, we're going to describe how this cell works, and we're going to put it down on paper. We're going to show you how an electrochemical cell actually has electrons that are flowing from one place to the other. So make sure you've got a paper and a pencil handy, and at the top of the page you can put down section 20.3 voltaic, aka galvanic cells. So these are named after Alessandro Volta or Louis Galvani, and those are some of the people in the 1800s that were some of the first people to describe these things known as batteries or electronic cells, things that transferred electrons through an external pathway. And these devices that transfer electrons through an external pathway are super duper popular in the world. You, as a matter of fact, use them all the time. You use a battery in your phone, batteries in lots of different devices. Here's an example of some batteries right here, and that's what the lemon battery is. That's what we're going to describe right here. Albeit, it can be many different chemicals as long as they're not the same as each other. So to describe the cell, we're going to actually draw it as two beakers. Make sure you take a lot of space like this and leave lots of room here at the top, because we're going to draw lots of connecting pieces. We're going to take and we're going to have two beakers, and in one beaker we're going to have a solution of zinc ions. It could be zinc nitrate, it could be zinc chloride, just so it's something soluble. And then over here we're going to have another beaker, and this one's going to have copper ions or copper nitrate. And then we're going to take and we're going to put a piece of zinc solid inside of here. And then over here we're going to put a piece of copper solid right here. Two dissimilar metals in contact with their ions. Now in the lemon battery we've got two different similar metals, and they happen to be in contact with a electrolyte solution, one that has positives and negatives, and that's what allows the electrons to flow, or the current to flow. Then we're going to take this zinc, we're going to attach a wire to it, we're going to run it here, and we're going to connect it to what's called a load. And the load right here could be a light bulb. It could be a voltmeter, like I have right here, or it could be something else that's going to consume the electrons that are going to flow. And then we're going to hook it up to this copper electrode over here. Each one of these metallic pieces is called an electrode, because they're the ones that conduct or have the electrons flow through them. Now if I hook this up, I'd have a half reaction going on here in this beaker where zinc solid would become zinc positive 2, and it would lose 2 electrons, and these electrons would flow right here through this wire and be attracted to the copper, because copper has more of an attraction for electrons, more opportunity to be reduced than zinc does. And then zinc would undergo this reaction where copper plus 2 in the solution would see those 2 electrons. It would grab onto them, and then it would form copper solid. And so these electrolytes would become copper solid, and this electrode would actually start to get a little bit larger because more copper solid would be plated onto this electrode. Whereas the zinc solid right here, this one would start to get eaten away and would become more zinc positive ions, aqueous right here, and would actually dissolve, I guess we'd call it. The fancy name for the place where oxidation takes place is called the anode. And the fancy place where reduction takes place, reduction is the gain of electrons, is called the cathode. Oxidation, remember, is the loss of electrons, and reduction is the gain of electrons. Now, when this happens, the electrons would come over here, and then we'd have a neutral copper. And the electrons would be lost here, and we'd just lose the electrons, and no more would happen. And so to make this continuous flow of electrons occur, we need to add one more piece to this diagram. We need to add something that allows this current or these charges to flow continuously. And this piece that we add is called a salt bridge. And a salt bridge can be many different things. Mechanically or engineering-wise, it can just be a piece of paper that has some salt solution on it. It can be the inside of a lemon because it's got a lot of juice inside of it that allows the flow of positive and negative things. From here, the anions that are inside of this solution, the negative charged species, might be nitrate, might be chloride, don't know for sure then, when they have two electrons being given in here and then added to here, the anions are then pushed out because the negative parts push out the other negative parts. And over here, the zinc positives that are created, they will pull those negative charges back into here. And so the anions go through the salt bridge, back to the anode over here. And so in any battery, in any voltaic or galvanic cell, here are the pieces to know. So first of all, it starts at the anode. Electrons are lost there. The electrons go through the wire to the load. The electrons flow. This flow of electrons, by the way, is also known as current. And if you know anything about electricity, current is measured in amperes. And we'll take a look at amperes way at the end of this unit. The electrons enter the cathode and they reduce the cation that's in there, and the anions flow through the salt bridge back to the anode. And so it starts at the anode, electrons are lost there, they go through the wire to the load, they enter the cathode, they reduce the cation, and the anions go through the salt bridge back to the anode, where it all begins. Now, after you watch this video cast, there's a second video assigned to you that will put all of this into your memory very nicely and give you a really nice little diagram of how this works, and it'll do it all to music. Good luck.